Okay, so reciprocal inhibition. Now, typically when we hear of it, we're given the example, well, when your bicep contracts, your tricep relaxes, right? If you want to get one muscle to relax, just look at the muscle on the other side of the axis, contract it, and everything will relax. Well, that only occurs under certain circumstances. Now, let's take a look at what Sherrington originally discovered. Okay, Charles Sherrington, he's the guy who this law was named after. He never wanted it to be a law, but that's beside the point. What he did was he did an experiment where he laid out or discovered this circuitry, this reciprocal innervation or reciprocal inhibitory circuitry. As you can see, you've got feedback coming from something called a muscle spindle that feeds back to the homonymous muscle or to the same muscle. And then you also have feedback going to an inhibitory interneuron, which then communicates with the muscle of the antagonistic muscle, okay? Now, here's the key. This circuitry does indeed exist, and he found this by working with cats that were decerebrated. I repeat, these were decerebrated cats. Now, I don't think that you and I are working with decerebrated cats. Most of our clients, hopefully all of our clients, have perfectly healthy cerebellums. So this idea that when you contract your bicep, your tricep relaxes is specifically conditional. It is an opportunity. It can happen, but it does not have to happen. Okay? As a matter of fact, if when your quads contracted, your hamstrings automatically relaxed, good luck taking a step. You would fall over every time. Okay? Co-contraction is actually the real way that most of our motion takes place. Now, whether you have a co-contraction or reciprocal inhibition, all depends on the circumstance. It depends on the demand that is being placed on the body that the nervous system then has to solve. I'll give you another example. If you were to say, I'm going to pretend like I've got 100 pounds in my hand, I'm going to squeeze my bicep now, right? When you do that, you squeeze your bicep, you don't smack yourself on the face, do you? No, you don't, because your tricep provides the resistance. So because of the circumstance, you generate a co-contraction as opposed to a reciprocal inhibitory scenario, okay? Now, what most people are leaving out is that since we are not decerebrated, that means that there's information coming down from the brain that also influences these alpha motor neurons and this interneuron that I've indicated with these little pink arrows right here. So, hey folks, there's a lot of cool stuff that you can do with co-contractions, and there's a lot of cool things that you can do by trying to facilitate the opportunity to have reciprocal inhibition. But I emphasize, it is an opportunity, not a law. It is not a law, right? Scientists, when they talk about laws, they're talking about very specific circumstances. So folks, just to recap here, reciprocal inhibition is an opportunity. Every time you contract one muscle on one side of the joint does not mean that the muscles on the opposite side of the joint are going to relax. It's entirely dependent on the mechanical demand that is being placed on the body. Okay? Co-contraction is a really important way that we control the motion of joints. So if you're doing a squat, for example, if you are really working on trying to recruit those hamstrings, it does not mean that your quadriceps are just going to shut down or shut off, or your adductors or abductors, anything like that. It depends on the demand that is being placed on your body. And so that we can look at some cool EMG that helps us to understand this, we're going to look at, we'll look at some quad and hamstring, we'll look at some bicep and tricep, we'll even look at some abdominal trunk flexors, and we'll also look at some spinal erectors and see how they form these co-contractions under these circumstances that we typically think of, this one's on, this one's off. We're going to see how they work together. Oh, and here's one for you. Think about it. When you think about a quadricep and a hamstring muscle, you think of them as agonist-antagonist, right? One does one thing to the knee, the other one does the opposite to the knee. But I got to tell you, when you are walking or doing a squat, they are synergists. So does that mean all that circuitry goes away? No, not at all. It just means that reciprocal inhibition, again, is what? It is an opportunity, not a law.